But the secret's in the pressure. That's what a senior KFC production engineer revealed when I asked what most people misunderstand about their famous chicken. After witnessing their factory operations firsthand, I immediately understood why. In this video, I'm taking you inside the heavily guarded facilities where KFC creates those perfectly crispy tenders that taste identical across 25,000 restaurants worldwide. You'll see production technology with precision like a state-of-the-art engine assembly line. The engineering behind each piece of chicken is more advanced than most automotive manufacturing processes. Ever wonder why KFC tenders always have that perfect, consistent size and texture? That chicken wasn't born ready for the Colonel's special treatment. In fact, the journey begins months before a single piece reaches the breading station. While you might assume any chicken can become a KFC tender, the reality is far more selective. KFC's chicken selection process resembles an elite talent competition where only the top performers make it to the big stage. The company maintains an exclusive network of supplier partnerships with facilities that must adhere to KFC's proprietary farming standards. These detailed rulebooks govern everything from the genetic lines of chickens to the specific composition of their feed. Mandatory requirements for any farm hoping to sell to the fast food giant. KFC works primarily with chicken varieties bred for optimal meat-to-bone ratios and muscle development patterns. These birds grow under strictly controlled conditions where lighting schedules and ambient temperature are regulated to ensure consistent muscle development. Once the chickens reach processing age, each bird must pass a 15-point quality check. Weight tolerance is measured down to the gram, fat content must fall within precise percentage ranges, and muscle development is assessed for density and texture. Birds failing even a single parameter are immediately diverted elsewhere. From the natural farm environment to high-tech processing, the transition is striking. At processing facilities, advanced computer vision systems, essentially AI-powered cameras, scan chicken portions at rates of thousands per minute. These systems analyze color variations, detect minute blemishes, and assess muscle fiber patterns invisible to the human eye. The technology works with remarkable speed. In less than 50 milliseconds, faster than you can blink, the system can identify and reject a chicken piece with a slight discoloration or microscopic texture anomaly. Picture a tender with just 2 millimeters too much fat on one edge, instantly flagged and removed from the production line. The technology compares each piece against a database of millions of perfect chicken tender images, rejecting anything that deviates from the ideal. Chicken pieces are separated by size variations measured in millimeters, with only pieces falling within a 3% tolerance of ideal dimensions moving forward. This ensures each piece in your box cooks at the same rate and delivers consistent texture. For pieces that make the cut, they move to a sophisticated marination phase. Rather than simple soaking, KFC employs pressure injection technology, hundreds of microscopic needles that force marinade deep into meat fibers. This system maintains exact distribution of flavoring throughout the entire piece, a far cry from the dip and soak methods used by smaller operations. The pressure-based approach ensures the Colonel's blend permeates every bite. The machines adjust injection pressure based on the density of each piece, ensuring even smaller tenders receive the same flavor profile as larger ones. The marinade composition remains one of KFC's closely guarded secrets, but the injection system itself is equally valuable intellectual property. The marination fundamentally alters the protein structure of the chicken, creating the foundation for that signature KFC texture competitors have failed to replicate. Before reaching the breading station, the marinated pieces undergo a comprehensive 27-point check, evaluating everything from pH levels to moisture content. Specialized probes measure electrical conductivity of the meat, indicating perfect marinade absorption. Only pieces meeting every criterion continue down the production line. The marinated chicken now enters the most heavily guarded zone in KFC's production facility, the breading station. While you might think chicken breading is just tossing meat in some flour, KFC's process more closely resembles a precision engineering operation than cooking. Biosecurity level access controls protect this area, with ingredients arriving from separate locations to ensure no single employee knows the complete formula. It's not paranoia, it's protecting a billion-dollar secret that competitors have tried to duplicate for decades. Upon entering this sanctum of crispiness, each tender begins a journey through what KFC calls their signature texture development system. The first surprise: the famous 11 herbs and spices aren't simply mixed together in a single batch. Instead, multiple proprietary blends are layered onto the chicken in a carefully orchestrated sequence. Even the flour itself isn't ordinary. It's custom milled to exact specifications of particle size and protein content that affect how it adheres to the meat. The actual application begins with a proprietary tumble and press technique that's protected by multiple patents. Unlike conventional breading that applies coating all at once, KFC's method builds layers through alternating dry and wet phases. This creates those distinctive craggy edges that provide maximum surface area for flavor and crunch. The machinery resembles pharmaceutical equipment more than kitchen appliances, with precision-controlled tumbling drums and compression stations. Environmental control in the breading room reaches obsessive levels. Humidity sensors maintain moisture levels within 1% of ideal conditions. Too dry and the coating won't adhere properly. Too humid and it becomes gummy. Temperature is equally critical, with dedicated HVAC systems keeping the air at exactly 68 degrees Fahrenheit. Even a 2-degree variation can alter how the breading behaves and attaches to the chicken surface. Most fascinating are the specialized gloves worn by workers overseeing the breading process. These aren't ordinary kitchen gloves, but custom-designed implements with textured fingertips that create precisely the right amount of pressure during the hand-finishing phase. The glove material itself is a closely guarded secret, developed specifically to create the perfect friction coefficient against the coated chicken without removing too much breading or compressing it too densely. After machine application, each tender undergoes a final hand inspection where technicians with years of experience make subtle adjustments to ensure ideal coating distribution. These experts can spot flaws invisible to the untrained eye, a slightly thin spot on an edge or uneven texture that would affect the final product. It takes months of training before an employee is certified to perform this critical quality check. Once properly coated, the tenders travel across a series of gentle vibrating conveyors that perform a vital but counterintuitive function. Rather than adding more coating, these platforms precisely remove excess breading while preserving the texture pattern. The vibration frequency is calibrated to different zones of the conveyor, with stronger vibrations at the start gradually becoming gentler, all to achieve what KFC engineers call optimal particulate distribution. This entire process is monitored by weight sensing technology that measures each batch to ensure exactly 36% breading to chicken ratio by weight. This specific proportion creates the perfect balance between meat and coating, enough to deliver that signature crunch without overwhelming the chicken flavor. Quality control systems automatically reject any batch falling outside a 1.5% tolerance of this target. What's most remarkable about this breading technology is how it addresses competing culinary demands. The coating must be substantial enough to create crunch, but porous enough to release moisture during cooking without becoming soggy. It needs to adhere firmly during frying, yet provide clean bites without flaking off excessively. Achieving this balance required years of food science research and engineering. The patented 7-stage coating process represents KFC's true innovation, not just the spice blend, but the structural engineering of the breading itself. The layering method creates microscopic air pockets that expand during cooking, creating that distinctive texture that competitors have failed to replicate despite decades of trying. Think of it as creating edible architecture, with each layer designed to react differently to heat and moisture. Those microscopic air pockets in the breading are just half the equation. They need something to activate them. What Colonel Sanders discovered wasn't just a recipe, but a cooking method so powerful that modern KFC factories use industrial pressure fryers operating at conditions that would literally explode your home kitchen appliances. The history of KFC's success isn't really about the 11 herbs and spices. It's about the Colonel's true innovation: commercial pressure frying. Back in 1939, Sanders discovered that cooking chicken under pressure dramatically reduced cooking time while creating that signature texture impossible to achieve through conventional methods. What began as a modified pressure cooker in his gas station restaurant has evolved into industrial cooking technology that forms the backbone of KFC's global empire. The science behind pressure frying is fascinating. When chicken enters these specialized fryers, something magical happens. The extreme pressure, reaching up to 15 psi, raises the oil's boiling point well beyond normal frying temperatures, creating a moisture sealing effect that works in seconds. This pressure barrier prevents natural juices from escaping while simultaneously forcing oil into the microscopic architecture of the breading, not into the meat itself. The result? Chicken that stays incredibly moist inside while developing that distinctive crunchy exterior. Modern KFC production facilities feature continuous pressure fryers that dwarf anything you'd recognize as kitchen equipment. These industrial behemoths stretch nearly 50 feet in length with conveyor systems that precisely precisely control the chicken's journey through multiple cooking zones. Each fryer operates as a sealed environment with carefully regulated pressure gradients that change as the chicken moves through the system. The technology behind these fryers represents cooking engineering at its finest. Digital control systems monitor and adjust 23 different variables throughout the cooking process, from oil temperature at different depths to precise pressure curves that fluctuate by the second. Specialized probes measure factors like moisture release rates and protein denaturation in real time, making micro adjustments to ensure perfect results across thousands of pieces. Oil management alone is a science at KFC. The cooking medium isn't just any oil, it's a proprietary blend designed for specific smoke points, flavor neutrality, and pressure performance. This carefully formulated oil undergoes continuous filtration every 30 minutes through a system that resembles something from an oil refinery. Computerized analysis detects minute changes in composition, automatically adjusting cooking parameters or triggering replacement when needed. The precision extends to environmental controls surrounding the fryers. Air pressure systems maintain positive pressure in the cooking area to prevent contamination, while temperature gradients are mapped across the entire production floor to account for how heat movement might affect the cooking process. Nothing is left to chance. What happens after pressure frying is equally impressive. Each batch passes through thermal imaging stations that scan every piece, verifying internal temperatures have reached exact targets for both food safety and optimal eating quality. These systems can detect temperature variations of less than 1 degree Fahrenheit across the entire surface of the chicken, instantly identifying any piece that doesn't meet standards. This quality control continues with physical checks conducted every 7 minutes throughout production. Trained technicians perform tactile tests, measuring factors like crust hardness, internal moisture content, and even the specific sound the breading makes when broken. These seemingly subjective qualities are actually measured against standardized metrics developed from thousands of consumer taste tests. The most remarkable aspect of this technology is its scalability. A single KFC production line can process more than 2,500 pounds of chicken per hour, maintaining quality that's statistically identical between the first piece and the last. The combination of precision equipment, continuous monitoring, and automated adjustments creates a system that delivers consistency at a scale that would be impossible through human effort alone. After all that precision cooking, KFC faces an even bigger challenge: how to preserve that perfect texture until it reaches your local restaurant. Most frozen foods develop those telltale ice crystals that destroy texture, but KFC engineered a solution that takes tenders from piping hot to colder than Antarctica in less than 120 seconds. Imagine a high-stakes race against time, where every second means the difference between preserving perfection or losing it forever. The moment a freshly cooked tender exits the pressure fryer, that perfectly crisp exterior and juicy interior starts deteriorating. Within minutes at room temperature, the signature texture begins to fade. Traditional freezing would be catastrophic. Slow cooling creates large, jagged ice crystals that puncture cell walls and leave chicken rubbery and dry. KFC's answer: a flash freezing tunnel system that functions essentially as a time machine for chicken, halting degradation in its tracks. These 60-foot tunnels create temperature conditions more extreme than anywhere on Earth. Tenders enter at around 175 degrees Fahrenheit and immediately encounter liquid nitrogen sprays, reaching temperatures as low as negative 321 degrees Fahrenheit. The genius of this system lies in how it applies this extreme cold. The nitrogen creates a temperature gradient working from outside in, instantly sealing the exterior of each tender before the interior begins to freeze. In the high-precision world of food manufacturing, texture preservation has become as critical as safety measures. The first 20 seconds are the most critical in the entire freezing process, explains food preservation specialist Dr. Sarah Mitchell. If you don't lock in that moisture immediately, you'll never recover the original texture no matter what you do later. The journey through this culinary time machine isn't a simple cold plunge. Each tender passes through 7 distinct temperature zones, each calibrated to prevent thermal shock that could crack the delicate breading. Engineers monitor the temperature transition using thermal imaging cameras, automatically adjusting nitrogen flow and conveyor speeds when needed. After about 110 seconds, tenders reach minus 40 degrees Fahrenheit, the point where Fahrenheit and Celsius scales converge and molecular activity essentially stops, preserving texture, flavor, and moisture perfectly. KFC's quality control continues beyond freezing. Random samples undergo laboratory testing that rivals pharmaceutical standards. Technicians measure measure moisture content, breading adhesion strength, and even cellular structure through microscopic analysis. One fascinating test measures the exact sound frequency when breading breaks. This crunch signature must fall within specific frequency ranges correlated with customer satisfaction. We can predict with 96% accuracy how a consumer will rate the texture experience based solely on the acoustic profile of the breading, explains food sensory scientist Dr. James Wilson. Tenders that pass inspection move to high-speed packaging lines where robotic systems place them in specially designed containers with thermal barriers and moisture control layers. Each package is sealed in a modified atmosphere that removes oxygen to prevent oxidation and flavor degradation. What most customers don't realize is that this flash freezing process actually contributes to flavor development. The rapid cooling creates microscopic fissures in the breading that expand during final restaurant cooking, creating additional crispy texture elements that wouldn't exist otherwise. Those microscopic fissures in the breading are just the beginning. While the factory creates the foundation for perfect chicken, the true test happens far from those high-tech facilities, in your local KFC kitchen. Ever wondered why even professional chefs with identical ingredients can't replicate that signature KFC crunch at home? The secret lies in what happens after those flash-frozen tenders leave the production line. KFC's tenders face their greatest vulnerability during distribution. This final phase is where quality can break down for fast food chains. A single temperature fluctuation can destroy weeks of meticulous work. Understanding this risk, KFC developed a comprehensive logistics solution. Their custom shipping containers feature triple-layered insulation and temperature monitoring devices that alert distribution centers about any concerning changes. These specialized containers include air circulation channels preventing partial thawing and shock-absorbing barriers protecting the delicate breading during transit. KFC's logistics team has carefully mapped optimal delivery routes that minimize time spent in loading zones where temperature control becomes most challenging. This meticulous planning ensures that when tenders arrive at your local restaurant, they're in the same pristine condition as when they left the factory. We've had customers tell us they can taste the difference when our system works perfectly, says James Watkins, KFC's Director of Operations Training. That consistent crunch is the payoff for all the precision that starts at the factory and continues through every step of our global operation. The magic truly happens when these preserved tenders reach your local KFC. Behind those kitchen walls lies a military precision operation invisible to most customers. Every KFC worldwide uses identical Henny Penny pressure fryers with proprietary control modules, engineering marvels costing around $14,000 each. Consistency requires standardization, Watkins explains. That's why every restaurant, from Tokyo to Toledo, uses exactly the same equipment calibrated to identical specifications. Store managers run comprehensive diagnostics on these fryers daily, measuring parameters like oil acidity and pressure seal integrity. Any deviation triggers an automatic lockout until technicians resolve the issue. Staff undergo intensive training focused exclusively on tender preparation. They master precise loading patterns, timing, and extraction techniques that maintain the structural integrity of the coating. People assume it's just dumping frozen chicken in hot oil, says Marissa Chen, a KFC training specialist. There's actually a science to it. We teach techniques that ensure the perfect amount of excess oil is removed while preserving the crust structure. The cooking process follows a temperature curve almost impossible to replicate at home. The computerized system creates an immediate seal around the breading, then adjusts to properly cook the interior without burning the coating, before finishing to that signature golden brown. What's remarkable is the built-in quality control. The fryers detect if too many or too few tenders are being cooked and adjust accordingly. If the oil temperature drops too quickly, the system extends cooking time to compensate. Each fryer sends cooking data back to headquarters, helping engineers refine the algorithms. When KFC introduced thicker breading in 2019, they remotely updated every restaurant's cooking profile overnight. Once out of the fryer, staff placed tenders in specialized warming cabinets with controlled humidity levels that preserve the crispy exterior while keeping the chicken moist. A timing system ensures perfect holding conditions. This global standard, from factory engineering to final preparation, explains why KFC's tenders deliver that signature crunch in every location, every time. It's It's the culmination of a journey where nothing is left to chance. From a kitchen experiment in the 1930s to a global food engineering marvel, that's the KFC story. What began with Colonel Sanders tinkering with pressure cookers has transformed into one of the most sophisticated food production systems on the planet. Think about it. When you bite into that crispy tender, you're experiencing something that required more precision engineering than many automotive assembly lines. Each stage in KFC's production journey, from proprietary breeding standards to pressure frying, forms a culinary symphony where every element must harmonize perfectly. While everyone speculates about the secret recipe, the true achievement lies in creating millions of identical pieces daily with remarkable consistency. Next time you experience that distinctive KFC crunch, remember you're tasting not just chicken, but a triumph of food science and manufacturing precision that rivals aerospace engineering.